Hello, I'm Mohammad Nafkan Azamzami. Here I will present our work with Fazad Nur Aziza about GraphQL-based backend service development tool for CRUD operations, authentication, and authorization. So in developing GraphQL-based backend services, we need to define a data model, create, read, update, and delete operations, or CRUD, and then authentication and authorizations. There are repetition patterns in those implementations so that a large number of code writings are required. The aim of this work is to reduce the amount of code writing required by the developers. We can look at the GraphQL backend service architecture here. It starts when a query comes in. It's being processed by the query processor by validating whether the query input structure matches with the schema definition or not. Then we forward the query to the resolver functions that can fulfill the task. Those functions are then communicating with a database or any data source. The yellow parts are the components that the developers need to implement. A data accessing operation process, especially in CRUD operations, can be seen in this process diagram. First, a user sends a request with an input. We have to validate the input based on the defined API specification. Then we validate the request whether it is authorized or not by checking the user context information. If it's authorized, we then process the request by communicating to the data source as needed. After that, we then construct the output based on the API specification and send them back to the user. We can see that for each operation with the combination of each entity, we have to implement the input specification, the authorization validation, the operation process, the data definition in the data source, and the output specification. So there are a lot of components that have to be implemented that grows linearly with the total number of entities. For each implementation, we can generalize them with very general implementations that receive defined data model entities as the metadata to process the requests. So here we propose a GraphQL-based backend service development tool for CRUD operations, authentication, and authorization called Homura. So Homura, our development tool, will receive the smallest possible portion of the schema definition and resolver functions created by the developers. And it will generate the implementation required to build a GraphQL server at runtime. Those are the GraphQL schema, data model definition, and resolver functions. Homura works by reading all the necessary metadata about the data model structures, then generating the common implementations for them. We can see again the GraphQL backend service architecture here. In before, we would have to implement these three components. And when we use Homura development tool, we would only require to implement these small yellow parts only. The green ones will be generated at runtime by Homura. In the implementation design, the authentication uses token-based authentication method with JSON Web Token or JWT as the token representation. And it generates login and register resolver functions. And the subject context is chosen by the defined metadata of the user entity. The authorization validation uses user's token as the subject context. And the authorization rules is defined in the entities metadata. For example, in scenario 1, we have these functional requirements and the entity relationship diagram below. We would have to only write the data model along with the metadata in a form of GraphQL schema on the right side here. We can define which entity will be used for the authentication user context, the authorization rules, the proper pre-process rules, and etc. We also try in the second scenario where the relationship among the entities were more complex. And we would only need to write the schema in the right side here. So we tested the tool in the scenarios. The result shows the amount of code lines in the scenarios. When we're not using Homura, we would have to write 392 lines of code for scenario 1 and 585 lines of code for scenario 2. Whereas with Homura, we would have to write only 78 lines and 92 lines. The amounts were reduced by 80% and 84%, with the average of 82% line of code reduction. So in conclusion, the development of GraphQL-based backend services was successfully written in a single schema utilizing a development tool called Homura. The amount of code lines that needs to be written in developing backend services with CRUD operations, authentication, and authorization is reduced by 82%. For the future works, the implementation of Homura can be further developed to support the evaluation of relation attributes in the authorization validation, support other API protocols, such as REST API, and support other content types such as images and videos. That's all from our presentation. Thank you for watching and see you.